All right, welcome Metal Fab class to the third video in our safety video. Today we're going to be talking about tank stuff again. This time we're going to be talking, the last video we talked about pressurized vessels and how to be safe there. This time we're talking about volatility. And so if you're thinking about volatility, a good example of this would be the difference in volatility between something like water and gasoline. Obviously water is non-flammable, gasoline vaporizes easily and is very flammable. And so gasoline would definitely be much more volatile than water. The same thing applies here with the gases that we're dealing with. And so if you remember from the last video, two of the welding gases that we use, one is argon and the other is, in this class, is CO2 mixed with argon. We could also use CO2 by itself, but let's just start with argon. Argon is what's considered an inert gas. Inert means that it's not flammable. It doesn't really react with anything to create a flammable or an explosive mixture. And so argon is really very, very safe. A common use for argon is as an insulating gas. Argon is usually what's in between window panes in what's called an insulated window. So you usually have a double pane window for a house or something, and the argon is the gas in the middle because it's an inert gas. CO2, this is a mixture of argon and CO2, but CO2 is carbon dioxide. The di is where we get the 2 from. CO2 is literally what we exhale when we breathe out. CO2 is also considered an inert gas. It doesn't really combine with anything to produce a flammable or explosive mixture. We could also use just straight CO2. In this case, we're using a mixture of CO2 and argon for welding, but we could also use just 100% CO2 for welding. The reason why we don't is because this gas works a little bit better in the environment that we're working in. We'll discuss that a little bit more when we get into welding stuff, but I did want to, those are really the 3 main inert gases that we deal with is argon, CO2, and CO2 argon. We get over here to the torch card. Well, now we have 2 different gases. We have the green one is oxygen, the black one is acetylene. Let's just start with oxygen here first. Oxygen, obviously our atmosphere is 20% oxygen. We breathe it every day. In a 100% environment like this, oxygen itself is inert. However, oxygen is a fuel also for burning. You can't have anything nothing will burn without oxygen. It's a necessary fuel. In order to have a fire, you need to have a fuel, and you need to have oxygen, and you need to have an ignition source. Those are the three ingredients for a fire. So without oxygen, you do not have fire. When you burn something in a 100% oxygen atmosphere, it burns so much hotter and so much faster that it actually becomes dangerous to have a 100% oxygen atmosphere. So the only reason why we use 100% oxygen is to make stuff really hot. In this case, acetylene. We're going to be burning a fossil fuel in a 20% oxygen environment. When we do that, it doesn't burn very well, it burns very dirty. But when we mix it with oxygen, it's going to burn really clean and really hot. Okay? So the volatility of acetylene is explosive. If we fill up the room with acetylene and we light a match, acetylene is going to be very explosive. It's flammable. It's just considered a flammable gas. Okay? But what really gets to be concerning is when these 2 gases are mixed together. Really what we have the makings for here with both these is the makings of a bomb. When you mix these 2 gases together in an uncontrolled environment, that's when things can get very, very dangerous, and we could have a huge explosion because of that. An example would be if we were to turn the valve on in this room of both of these gases and walk away. We would fill up the whole room with lots of acetylene and lots of oxygen. If there were an ignition source, we could literally blow up this room. It would be very explosive. So that's why we need to make sure that when we use these gases, that we're using them under control, we don't have any leaks or anything like that, and that the valves are always in the right positions. We turn them on, we turn them off, we don't ever leave them on unless we're using them. Those are really the concerns about volatility with gases. Okay? Cut.